Right, in the last video, last lecture, we used this formula to find Laplace transform. This one right here, L25. This formula helps us to find Laplace transform of two multiplied functions when there is e power at, and f of t. So for example, I'll give one more example. So let's say if we have, I'll write it here on the side just in case. So let's say if we have Laplace of e power 3t, t is for 3t, I need a t here. So Laplace of t e raised power 3t. So this t is my function. We take Laplace of t and then shift the answer to s minus 3. Note that this minus 3 is opposite sign. This is a plus 3 and this is minus 3. Okay? This one is minus 3, plus 3. Right. And then we write Laplace of t, which is 1 over s square, and then we replace s by s minus 3. Kind of we substitute. So we substitute s equals s minus 3. When we substitute s equals s minus 3, so this is 1 over s square, s minus 3 becomes in the bracket. Now we are going to do the inverse of this. So let's say if the question is in exercise question number 11 says find Laplace inverse of 1 over s minus 3 square. Alright, the formulas we have, what are the formulas we have for inverse? Let's go back and see. Here is the list of formulas for inverse. We do have formula for 1 over s minus a, but not 1 over s minus a with some power. As you can see here, we have 1 over s minus a, but with a power square outside. So this formula, the one for e power at, it can work if it is only 1 over s minus a. There is no formula that fits this situation, 1 over s minus 3 square. So what we will do is, we will reverse this procedure. We will reverse this procedure here. So we are here, we are over here, okay? We are at this step, and we will go back like this, okay? So let's see how do we do that. How do we write the formula? First, let's start the inverse formula. Here is how we write the formula. Let's copy the formula from here. So this is our formula, L inverse of f of s minus a. Okay, so now note that there is not enough space here, but I'll write it again. So this one, Laplace inverse of f of s with s minus a goes to s. So now what we do is, we do the same step in reverse. So now s minus 3 will become s. S minus 3 will become s, and from here we will write the Laplace inverse. Okay, so let's try an example. Same example actually. Laplace inverse of 1 over s minus 3 square. So if I change s minus 3 to s, okay, s minus 3 becomes s. So what will be the situation? This will become s square. So s minus 3 I have put now quite the reverse of what we were doing before, 1 over s minus 3 square. So I treat this as 1 over, here I'm going to replace it with 1 over s square. Okay, so quite the opposite. Now s minus 3 becomes s. So we get this. Do we have a formula for 1 over s square? Yes, we do have a formula for 1 over s square from here. If n equals 2, then we can use this formula for 1 over s square. But what do we do with this part? Okay, so formula for 1 over s square is, let's write it over here, t, Laplace inverse of Laplace inverse of 1 over s square equals t, because Laplace inverse of 1 over Sn equals n minus 1 factorial. Okay, here 1 over n minus 1 factorial, sorry. I need more space here. 1 over n minus 1 factorial t power n minus 1. Okay, so n is 2, so 2 minus 1 1, no need to write, 2 minus 1 1, so t power 1. Okay, so that is t. But what do we do with this part? What do we do with this part? We have changed the question from s minus 3 to s. How do we compensate this? We will write e power 3t and like this. Let's see the steps here again. So we start here, we start over here. Okay, from this step to this step, s minus 3 goes to s, we take inverse of 1 over s square, it becomes t, and this one becomes e power 3t. So all the steps are reversed, exactly the same, they are reversed. Okay, let's do one more question and we will get the hang of it. I'll do side by side this time. Let me start with question number 11. Laplace inverse of 1 over s plus 2 cube. Okay, so our first we have to change s plus 2 to s. Okay, s plus 2 will become s, so this will become 1 over s cube, and then we write, what is the answer for 1 over s cube? It is 1 over 2 t square. Okay, and then for this thing we need to put e raised to the power minus 2t. For this term we add e raised to the power minus 2t, and this one is coming from, let's slightly pull it down to make better sense of it. Yeah, that's better. So there are two parts in the question. We change s plus 2 to s, but then this thing compensates for e power minus 2t, and this thing gives 1 over 2t square. This is from the formula, this is from this formula, the formula for inverse. Okay, so Laplace inverse of f of s minus a goes to s, and we attach e power at and then write the inverse of f of s here. If you look at this question, Laplace of half t square e power 2t minus 2t, what would it be? 1 by 2. What is Laplace of t square? And then shift s goes to s plus 2, and that would be 1 by 2, 2 factorial over s cube, s goes to s plus 2, and that is 1 over s cube. I'll write directly because 2 factorial and 2 is cancelled. S plus 2 same. So this one and this one are same. So this procedure from here to here, we are simply reversing this procedure. So we start with this point, shift s plus 2 to s, okay? Opposite, s plus 2 becomes s, and then we attach e power minus 2. Try one question. I understand that this will require some practice to get it very well. So try one question, very simple question. Let's try Laplace inverse of 1 over s minus 1 power 4. Alright, stop the video and give it a try. Right, so as you can see, it's a linear and a power outside. That gives me the hint that it's a shift theorem, okay? Because how do I know that I have to do the shift theorem? Always remember, how do we connect it with the formula? Because I can see none of them has a linear and a power outside. This is linear, s minus a is linear, but no power outside. This one is just only s, no a, no minus a. This is square. So the situation in the question tells me that it's a shift theorem. And inverse 1 over s power 4 and s minus 1 goes to s. Okay? Now 1 over s4, that is the formula we have, 1 over s4. This formula will help me here. So this one becomes 1 over 3 factorial. What has gone wrong here? And a t cube, and then e power t because of this. Okay? This will give me e power t. Do not forget to attach e power t. The inverse, I'll use a different color for this. The inverse is this part, and this shift is giving e power t. So my final answer would be, which is equal to 1 by 6 t cube e power t. And, okay, I'll stop here because you'll see a quiz after this. I would like you to do that. So far, we are doing inverse questions of the kind. For example, we have done Laplace inverse of 1 over s cube, which we can do directly by using the formula here, this formula here, 1 over s power n. So we can do is 1 over 2 factorial t power 2. So that's a very simple question. We have done Laplace inverse of 1 over s minus 4, which is again very simple, e power 4t, no powers on the so this formula here, L inverse of s minus a. Okay, no power on s minus a, so we can directly write e is equal to 4t. Or we have done Laplace inverse of 1 over s square plus, let's say, 16. Okay, so that is 1 by 4 sine 4t. Okay, nothing is multiplied with s square, so no need to use partial fractions or any power on outside. So this is simple formula, 1 over s square plus k square. Laplace inverse of 1 over s square plus k square, 1 over k sine kt. So that's that. And we have also done, in our last part of the video, we have also done 1 over s minus 4, let's say, whole square. Now look at this formula. This is different. 1 over s minus 4, e power 4t. This is different. This one tells me that it is first shift theorem. First I have to shift s minus 4. I have to make it s square. S minus 4 goes to s. Okay, so as you can see the difference now, and now I write the inverse of 1 over s square just like over here, and that is t 1 over 1, and then shift, and then this part gives me e because of the shift theorem. So this thing gives me e power 4t. Okay, so that is what we call shift theorem. We put s minus 4 equal to s. Okay, we put s minus 4 equal to s. So when we put s minus 4 equal to s, this thing becomes s square, and this part gives us e power 4t in the answer. This gives e power 4t. Okay? And this part, let's use a different color for it. This part, this blue part gives t. Right. Now there is another situation. As we go from here to here, we put s minus 4 equals s. Okay, and we write it like this: s minus 4 goes to s. That's how we write it. Let's remove all these prompts. Okay. Now we have a slightly different situation. Let's say if we have Laplace inverse of 1 over s square minus 6s minus 6s plus 10. Now we have a problem. Our problem is our formulas which has s square, this one, these 4 formulas, they do not have s term here, you see, s square and constant, s square and constant. Whereas the question has 3 terms, s square, constant and an s term. We must write this first as something like this: s minus something square or s plus something square. We have to write it like this. How do we do that? We will use, for this question, we will use our formula a minus b whole square, a square minus 2ab plus b square, or a plus b whole square, a square plus 2ab plus b square. And the trick we will use is called completing square. Completing square. I'm sure you have seen this before in calculus. I'll just quickly revise it, how it works. So let's start with s square minus 6s plus 10. As we can clearly see that there is a minus here, it means it is this formula with minus. Okay, so we are going to complete the minus formula. How many terms are there in the minus formula? There are 3 terms in the minus formula. First is a square. So a square minus 2 is fixed always. A is s. What should I put here to make this thing equal to 6s? Okay, that is the key step. This is the key step in the whole story. What should I put here? This one I have to think. So 3 I must put here because 2 is fixed, s is coming from this term, so s is fixed. Only term I can choose is this term, and I have to make it equal to 6s, okay, which is given in the question. So what if this is 3, then formula tells me b goes into b square, so this means this is 3 square. But I do not have 3 square in my question. I have 10. So I will do is I will subtract 3 square and plus 10. So this means this is equal to s minus 3 whole square plus minus 9 plus 10, or this is equal to s minus 3 whole square plus 1. Okay. So that's our square complete. Right. So now we replace our original function with this new term. Laplace inverse of 1 over s square minus 6s plus 10 equals Laplace inverse of 1 over s minus 3 square plus 1. Now we can do the replacement step. Now we can see it is in the form of s minus 3. Now we can say s square plus 1, where s minus 3 goes to s. This part of the formula we have in the formula sheet. 1 over s square plus 1. Laplace inverse of 1 over s square plus 1. we have it here, 1 over s square plus k square with k equals 1. So we can write sine of t, and this part will give e power 3t. Okay? So that is our answer then. So the key in the whole story in this type of questions, when you get let's look at this again. When you get Laplace inverse of 1 over s square plus as plus b square, something like this. Okay, I'll write an example which is easier to understand. 1 over s square plus 3s plus 4, or Laplace inverse of 1 over s square minus let's say 6s plus, we have done that one, plus 13. Okay, so these are s square plus as plus b, okay, or as square plus bs plus c, quadratic form with this s term. So that tells us that we have to do completing square. Let's just try one more for practice. How would we complete the completing square of s square minus 8s plus 13? Alright, give it a go. Pause the video and try to complete the square of s square minus 8s plus 13. Okay, again I can see that it is of the form a square minus 2ab plus b square, which will give us a minus b whole square, because there is a minus here. So we will start with our a square minus 2a. What should I put here to make it 8s? That is the key step. So what should I put here to make it 8s? I should put 4, and that tells me that I need 4 square extra. But when I add extra, I have to subtract as well to balance the situation, and then 30. Okay? 13 is already there. Now this one makes a square, okay, and that gives me s minus 4 whole square, and my extra terms are minus 16 plus 13, and that will make s minus 4 square minus 3. Okay, now you will see a quiz. So go through the quiz and come back.